Hi, and welcome to the next little video on indices. And we're interested in this video in indices which are fractions. There's an example, 2 to the power of 1/2. What does it mean? Well, let's take two of them and multiply them together. The rule of adding of indices there is that give us 2 to the power of 1, which is 2. Now, what other number have we met before where if you take two of them the same and multiply them together, you get 2? Well, the answer is the square root of 2. And so 2 to the half is the same as the square root of 2. Just another way of writing it. The half means square root of. So 2 to the half is the square root of 2. And in general, any number to the half is its square root. So that's a general rule there at the bottom. Another example, 5 to the power of 1/3. That's another fractional index. Let's have an investigate of that. Let's take 3 of those and multiply them together. The rule of adding indices tells us that we get 5 to the power of 1, which is 5. And so 5 to the power of 1/3 is the equivalent of the cube root of 5, because when you multiply 3 of them together, you get 5. So there's the rule, and in general, any number to the power of 1/3 is the cube root of that number. And in an even more general case, a to the power of 1 over c is the cth root of a, whatever the value of c is. Now, I'm going to put that rule at the top of the page because we're going to be looking at some examples now. What's 27 to the power of 1/3? Well, it's the cube root of 27, which you should know is simply 3. 32 to the power of 1/5. It's the 5th root of 32, which is 2. When you've got a fraction, well, if you remember, you just split the fraction. You get 16 to the half divided by 25 to the half, which is the square root of 16 divided by the square root of 25, which is 4/5. Another example, 81 over 65 to the power of 1/4. Well, that's both of those numbers separately to the power of 1/4, which is the 4th root of each of them. So that settles down to 3/5. Now, this is a rule we've met before in an earlier video. When you take the power of a power, in fact, you just multiply the powers together. And then if you remember, you can reverse them and split them differently. It doesn't matter as long as you've got a times b or b times a involved. Now, it's going to be useful for the next little technique, is when you get a fraction which is not 1 over something, but something else. In this case, we've got 8 to the 2/3. Now, the trick is to split that fraction. So I'm going to do it one way. That's 8 squared to the power of 1/3. So 2 times 1/3 is 2/3. 8 squared is 64. The third means it's the cube root of 64, which is 4. Now, I'm going to show you a different way where we split the fraction differently. This time we keep 1/3 inside the bracket and we just square the whole bracket. This time we get the cube root of 8 squared, which is 2 squared. And no surprise, we get the same answer because we're just doing the same question in a different way. Now, it's often this second way which is more useful because the numbers are slightly more easy, smaller and more friendly to use. Let's have a look. There's the rule again. Now, here's a fraction to the power of 4/3. I'm going to split it so that the 1/3 is inside and the 4 is outside. That gives us the cube root inside the bracket of 8/27, all to the power of 4, which is 2/3 to the power of 4, because 2 and 3 are the cube roots of 8 and 27 respectively. And so now we get an answer 16 over 81. And it's much easier to do it this way of splitting so that the 1 over fraction is inside and the numerator of the original fraction is on the outside, because the numbers stay reasonably small. If we'd done it the other way, we'd be doing 8 to the 4th divided by 27 to the 4th, and then taking its cube root, which is probably a little bit more tricky, certainly if you're doing it without a calculator. Now, one last thing. What happens if we've got a negative power? Well, we've had a video about negative powers, but we haven't had one with a negative fractional power. But there's no particular special worry about it, because the first thing you do is that you take the reciprocal of that fraction inside the bracket, and that gets rid of the minus in front of the index. By taking the reciprocal, we get rid of the minus. Now we just go some fairly similar working. I'm not going to show it all. And this one ends up with 81/16 as your final result. Notice that, of course, the difference between the two answers is one is the reciprocal of the other, and the difference between the two original questions is just this minus sign in front of the index here. So the minus really just turns everything upside down, including the final result.